Start. Good morning, everyone. Namah Shivaya. So, how you are enjoying the sessions? So, we will start with machine learning today. At least a few models we will learn today. How to. So, looking at. Can I have the. Start. Good morning, everyone. Namah Shivaya. So, how you are enjoying the sessions? Okay, so looking at this picture, maybe you would have seen this often, this kind of situations very often. When you see cricket, when you see football, when you see hockey or any of the games, when it is a very critical moment, and the player loses to place the goal, that would be a slight miss. Do you all agree with me? He would have practiced for years, but then when it comes to a global match, it's unpredictable. Sometimes things can go wrong. A small miss, maybe the footballer, when he puts a goal, it flies up above the goal post. It's possible, right? The angle with which he has kicked may not be as perfect, and that's why it got missed. We also can see, oh my God, a little perfection could have helped him have the goal, right? We would have definitely thought that, is it not? But then we know that a little perfection could have really helped. How does he get this perfection? By practice. During the game, he has to be fully focused. The player has to be fully focused. So many factors are involved, and if everything works out perfectly, he gets a goal, right? So, during his practice, if he knew exactly in which angle, if he kicks the ball, a football, the goal can be placed from a specific position, he doesn't do any mathematics to learn that. He is doing it by practice. He is trying it out from different positions and trying to identify if it is this position, if it is this position, he makes a calculation. Mentally, his brain is making a calculation before he can place. There is some physics at work. There is some distance calculations at work. There is a mathematics at work, right? And there is some dynamics based on the weather conditions. In cricket, I think those situations are very popular. If the pitch is not really good, the bowling is going to be affected, right? So, those kind of factors actually influence the way you succeed, influence the way you achieve your target. In our life, almost every day, everything, you start from here, maybe from this campus to the airport, you definitely need to know the traffic conditions, otherwise you will be late. Almost every situation, we have to think twice or make a decision before we try to achieve the target we want. Reach a target. If you do a business, you have a target profit. At least 10% of profit I should get this season. Right? You have a target to achieve. Everything in your life, you have something to aim for. You have a goal, you have a target to achieve. What factors influence this target? How can you model these factors so that you can achieve this target? Machine learning can help you. Okay? So, what is machine learning? What is data? What is modeling the data? How do you use models in your life? Have you ever heard of any model in your life? Have you seen any model in your life? Let's say an aeroplane model. Have you seen? A car model. Have you seen? The real aeroplane is different. When I say it is a model, it is one step behind the reality. You are actually seeing a smaller version or a version which is similar to the aeroplane, right? You can see a child's model, a toy model of aeroplane, a toy model of a car. A model is something, an abstract idea of the reality. If you can make abstract idea of any situation where you want to achieve your target, these abstractions can help you how to achieve the target, understand how to achieve the target. If you can have a toy car using a remote control, you can actually see how a car moves. In reality also you can see how a car moves, but then in a model how it is actually working. You don't open a car to understand how a car works, you have to look at a model. These days people do it on computers. Modeling in computers has made all the difference, and machine learning has become a reality, and this is creating magic in our lives. How much difference it can make in your business if you can model your business. What kind of business you are doing, model it. You are using a car, model it to understand how the car works. What kind of business you are doing, model it to understand how your business is working. Why you got into a loss last week? How can I get profit next week? You have modeled your business. You can look into the model and see which factor is affecting more, which factor is actually influencing the business target that you are trying to keep. Can you actually keep a target and then fix all the factors and then ensure that you get some amount of success? Can we be exact using a model? You create a model, a prototype, you run it. Can it be exact version of the reality? We need to understand that. Machine learning talks about models, means it also talks about approximations of the reality. But with approximations you can learn a lot, you can experiment a lot, you can experience a lot, and you can make yourself an expert. But then in reality you have to do a checking. You have to verify it. You have to actually implement it, run it, test it, validate it, use it. Right? You create a model. 2 days back, a pilot has created an indigenous flight in India, in Mumbai, in his apartment terrace with a 6-seater aeroplane. He has flown it successfully. He has flown it successfully. So, he had done it for 18 years. He had modeled it for 18 years. The reality came only this week. Okay? So, you can model anything in your life using what? Using mathematical representation, simple mathematical representations you can model. It all depends on how correctly you want to model it. Can I be really approximate? Can I be very abstract and model it using very, very simple? If you look at children that can actually run. So, you can have a model that can be very simple, that can be very complicated, and as close to reality as possible. If you have a very abstract model, you can start there, and experimentation there is very easy for you. Machine learning allows you to create models of any operation, any event, so let's say what kind of things you can model. So, you need to understand that. What kind of things can I model? How will I model it? How will I learn from it? How will I first of all create this model itself? Okay? If in this particular example of a football, if the kick of the ball varied only depending on one factor, that is the angle with which he is kicking, do you really think so? Is it only one factor that influences the kick? No, there are multiple factors, right? Now, all these factors, what effect do they create on this kick? Putting together a combination of all these factors, multiple variables come into play. If you have to calculate, the human brain finds it harder, right? How will you say, okay, the weather is this much hot, the ground is wet a little bit, and he's standing in this position. All of this you try to calculate manually. I mean, by looking at it visually, you try to calculate, it's going to be very difficult for you. Give it to your computer, it will do it in no seconds. So that's why we go for models to learn difficult situations. Next. So for example, let us look at the agriculture. A farmer, he wants to know, he wants to understand how much crop yield he is going to get. He has 1 acre of land, he has put paddy, how much yield he is going to get. This is something that he has to do on a regular basis, right? But when he understands how the yield improves based on the factors involved during his agriculture process, if he understands that the yield is improving because of this, because of this, because of this, there are so many factors, so many nutrients, the climatic conditions, the water supply you have, the quantity of water you give, the timing, and any fertilizers or any pesticides, which organic or inorganic chemical pesticides, you will have to use pesticides to save them from the insects. So all of these, he does one, he says, okay, today let me do this, today let me do this. He has a random calculation, and then he says, this is the way to improve my yield. If he can model this process, and understand, if these factors, this combination of factors work together, I will get a better yield. That is an estimation of how much yield I will get. If you can model a process, you can also estimate how much yield you will get. So let us say in the past 3 years, a farmer has made an estimate, he has understood, I did the process, I got this yield, I did this process, I got this yield. So in different seasons, he is making these calculations, and he has this information with him. Using this, can he predict the next year? Can he predict the future, saying that if I do these things, my crop yield would be this much? Can he do that? It's a very simple, very understandable logic for a farmer. If he knows how much he has to do all of this in this particular season, and he has got this kind of yield before, he can definitely make an estimation of what yield he will get it next time, right? So what is? Now this seems very simple at the outright. It also actually is very simple in the inside too. Creating a model, learning from the model, all of them are actually simple from the inside also. Looking back at the football model, the angle and the position, the distance from the goal post, you don't have to create mathematics for that. Physics has already defined how this will work, how this law of motion works. Newton's laws of motion has already defined that. You already know those definitions, you implement them. When you create a model, that's what you will do. You are modeling the process of perfecting the goal, placing the goal, kicking to the goal post, right? You are perfecting that process. That process doesn't have to be done from scratch. You always can involve somebody or already existing scientific definitions of that process, and then you can add some influencing factors for the same. Laws of motion, it's very abstract. It doesn't talk about weather conditions, whereas it talks about if the friction is so much, this is how the motion would be, right? It talks in terms of friction. If you have to translate it to the real world, it will be in terms of weather conditions, the force, the player's body structure, height, and what kind of force he can apply, the capability of the skill set of the player, all of them become more real world parameters. Okay. So once you create a model, when you create a model, you do it by training on already what you know. if this is the position and this is the angle which, then you will get it hit. So that information you will keep. You will also understand the laws of motion. Putting together, you will train and create the model. Once you create a model, the process model, you will also test it. So from the real world, what do we have to get to create a model? You have to make observations of the real world process. All these observations, you call it as data. From this data, you analyze the data, learn from the data. So learning from data is the order of the day. If you look at whether tsunami will occur tomorrow or today, when you stand on the seashore, I am sure almost everybody will remember the tsunami that hit Indian shores in 2004, right? So you will always have that at the back of your mind. You also will look for symptoms that could have caused tsunami, and you also look for such symptoms when you stand on a seashore. So those symptoms, from the observations, from the data that was collected, from any process that has happened before, those symptoms, you look at those, you call them as patterns. In computing terminology, you call them as patterns, symptoms, patterns. You look at those patterns, use that to model. You are analyzing the observations and then use that to model. Once you create the model, you make predictions. See, in future, if these things happen, then this is the result. This is the estimate. This is what is going to happen. Okay? So when you model, we need to understand why, what are we looking at in the process. In the same football match, I can look at two different problems. One problem is how the combination of the players in my team, how efficient is my football team, how successful they are. This combination, is it really worth the effort? Or I can look at the same problem where for a particular player, which positions for him, that every player has a strength from a particular distance, from a particular angle, they have strengths. Even if it is a volleyball, there are some people who can give shots, right, who can forcefully place the ball in particular positions. There is a strategy, talent in every player. So those are kind of aspects you want to model, that kind of problem you want to see. So why you want to model, you have to be clear with that. Find what you want to know from this model, and what do we already know, what kind of observations do we already have, and what are the assumptions we are going to make for the given process and the scenario. What are the assumptions we are going to make? Let us make the assumptions that there is no rain for the cricket match today. Then only you can decide what can happen. So those kind of assumptions, some of the factors you may have to assume. There can be factors which will change every day. There can be factors you can fix. You can assume and fix it. You can assume and fix them. For the whole month, I will use some of the factors I will fix. They are called as parameters. So from the observations that you make for a particular process or an event which you are trying to solve, you look at a problem there, you want to model it, and you want to actually understand how it works so that you can predict and recommend to a player how he has to exactly play. What kind of practice will actually help him in being successful as a goal, a person who puts the goal. So, and how should we look at this model? What are the ways in which we have to look at this model? And what is it that one particular value that your model is going to predict? Or is it a set of values that your model is going to predict? You have to do this, or you just do this, how much, what are the things that your model is going to predict? And is it valid? You have to test it. You have to have a known scenario, a known situation. Give your model, you should test it, you should validate it. And finally, this validation, you call it as, verification also. Here, valid and verification, in machine learning terms, it is actually testing and validation. Testing would be, you already know what happened, you already know what are the factors, how the situation was, that particular instance, what happened, give us input to the model, and this model should give you exactly what happened. Then your model is correct, or at least close to what happened. An approximate estimation of the reality it should be able to give. Verification means then you should different scenarios which you do not know what happened actually, those you can test, or a totally different scenario with a variety of parameters where it's not very clear what happened exactly. This could have happened, you have uncertain situations and instances, you can verify the model for that. Okay? And how do we improve the model if we are not close to the reality of prediction? If we are not able to estimate what happened correctly, how do you improve it? And how do you use the model finally? So this is how, these are the steps in the model, and I think this could be, you could just check this later on. And what are the components of a model? You will have factors in the model, you call them as variables. There are two types of factors, one is fixed, the other one would be variable. So those variables for which, for this particular period, I am going to fix values, you call them as parameters. And every instance or every test that you make, every test scenario that you make for the model, it's going to vary, they are called as purely variables. So variables can either be parameters or purely variables. And then you have relationship between the factors. If the weather condition is very, very poor, maybe the athlete also may fall sick. There are some relationship between the factors involved, definitely. So you have to, the model will have relationships among the data. The variables and parameters, the model will have a relationship. How it is influencing each other, that's what should be. So what you call as a model is these are the things. You will have variables and parameters, relationship among these variables and parameters, and finally you will have data. Okay. So you say that I am related to him as a sister. Okay. Data tells me that I am really a sister, right? That's what you will do with data. Data would be actual observations. Variables and parameters would help you model those observations. So your model will actually have variables and parameters plus the relationship among these variables and parameters. We will look at a sample model and we will see what it really means. Okay. So what is data? Can you tell me what is data? Some examples I put here. In logbook, you make an entry. When you get into the lab, you go out of the lab, you go to the hostel, you get inside the hostel. When you go home, you make a mark. All of these are entries that you make into like a logbook, right? That is also data. So what do you really mean by data? You take, let's say, a survey, an opinion poll, exit polls of yesterday's elections, right? It was a survey was taken, and that is also data. When you say survey, you will have a set of questions, and there will be answers to the questions from different people. Now all of them you jot down and then you create a table, then you call it as data. So you have a questionnaire for anything. You could always make a feedback, get a feedback. You give faculty feedback. You give a feedback for the workshop. You give a feedback for anything. So you have a few questions, you answer them, you are actually posting your opinion. There again it is data. Now if you take instruments, right? Well, how is this a particular experiment? How does it work? You repeat the experiment multiple times and see how it works. Every time you make the experiment, you do the experiment, what you record is data. So there are actually real-time data, off-time data, offline data, and you have continuous data, discrete data. Can you give me examples of continuous and discrete data? Continuous data. Our heart beats continuously. So an ECG shows continuous data. What about discrete data? Temperature of this room, it's not going to vary every second, right? The data, 1 hour once you can check the temperature. It slowly increases, but you actually take the nature of the data can be continuous or discrete. You can do measurements continuously or discrete. We are talking about the nature of data. Temperature doesn't change every second. You agree with me? Right? So that is actually discrete data, continuous data. So you make observations on discrete or continuous data. What is real-time data? Can you give me examples of real-time data? Live match is going on. Cricket scores is real-time data. The match is already over. Now you look at Cricket World Cup scores, how the matches happened, all of that. It's already recorded. It is over. The event is over. The event is happening. It's real-time data. It is over. It is offline data. Now the data also can be different types: text, image, audio, video, speech, right? All these are different types of data, the format in which the data is available. So, and then the next question is, what is a data point? These two are very important ideas. Once for all, you have to clear it off. Because machine learning is just about, if you understand what it is, you just need to apply it. You don't create machine learning models, actually speaking. A lot of models have been already created and they are available as a standard and have been proven to be very, very successful. So you can use a lot of them. You don't have to create. But you need to understand what is data and what is a data point. I said data is observations, right? Different kinds of data we saw. Now what is a data point? One measurement is one data point. You conduct the experiment 10 times, you have 10 data points. So data point is actually not an x comma y. It could be a set of values. It could be the temperature, the humidity, the water level. It could be the, what is the air pressure. All of them put together could be one data point. One measurement is one data point. Okay? So one entry, one person's answer, you get from 100 people. So 100 data points are there. One unit of information is a data point. So if that is the case, naturally, if it is a scenario, a game, then at one instant of time, what is happening is one data point. So what is a data set then? A data set is a collection of data points. So if you look at the data set, collection of data points, every row, you can look at it as a table and then say, my first data point forms the row, second data point forms the second row, or you can do it column wise also. By standard, for ease of, or for a standard of, common way of working with it, every row is usually treated as a data, is stored as a data point. So you look at a data set which shows examples of the football game where the players just missed posting the goal. We will look at, so we will have a data set where you have videos of players just missing the goal by something, right? Missing the goal. So you have a data set of videos, 10 videos. Different players, they just start putting a goal and something happens, it goes off. So like that, can you get a data set like that? Is it possible to collect a data set like that? So what is the problem here? My problem is to find out why the failure happened. Why a player failed to post his goal in a football game. That is my problem statement. My data is the videos of such scenarios in different games, different players. And what is my data point? My data point will tell me for every video, if I have 100 videos, okay, every video is a data point. I have 100 videos, every video is a data point. Now within each video, I can actually say, within one data point, within one video, I can actually say this factor was this much, this angle was this much, this is his position from the goal post, all of those things, all of those factors, the values, the exact values, that will be my data point. So it can be a series and then it failed. That is the final result. What was the result? What was the result in that data point? So you call, generally you call them as, the predicting factors, the influencing factors, the causing factors, the cause factors. And what is the response? It failed. Because of all these correct distance, angle, position and all of that, actually he failed posting the goal. That is the result, the response, okay. So you call this as that a data point has a set of predictor factors and a response factor, a value for each of them. That is your data point, okay. Now there can be, in case I don't know what the response is, if these, let us say, okay, there are videos which has a combination of both, he posted the goal successfully, posted the goal unsuccessfully, he failed to post the goal, right, he failed to put the goal. Let's say you have a combination of these videos. Now from these videos you may want to segregate which was successful and which was not successful, okay. You can do it in two ways. One is your data point should contain the information that it was successful. You have all the factors, the cause factors and the target, the response, the result. The result is also there. If the result is also given in your data point, when you try to model it, model from the data points, you call it as supervised learning. What is supervision? Supervision is there is some help for you to learn, right? So there is some help for you. In this particular set of factors, for this data point, it was actually successful. You have